Alright guys, today we are going to finish up graphing quadratics. Today we're graphing quadratics in standard form. This is a foldable that's attached to this video, so if you can print off, do. If you can't, well, get a piece of paper and create a foldable. Go ahead and fold it in half and we're going to talk about it. Okay, so in standard form, it's a little different. We do not have the vertex, which means we don't know where to start this graph because we have to put the vertex in the middle. And we're going to cross this one out. We don't care about this one. So we have to put the vertex here. The problem with that is we don't know what the vertex is, okay? So there's not a lot we can do yet. So here's what we're going to do to find the vertex. You can go ahead and turn your calculator on. You have to have your calculator. Press y equals, if there's something there, you're going to clear it out. And then you're going to type in x squared minus 6x plus 10. Okay? Then you're going to press second graph, like we did with exponential and like we did with vertex form yet. Not yesterday, last week, whenever we did it. So second graph. And we have to find the vertex now. Okay? To find the vertex, we are looking for where some of the y values repeat. For instance, 26, I don't see that twice in this line. 17, I don't see that twice. 10, I don't see that twice. 5, I don't see that twice. 2, oh, I see that twice. That means, see how it's 2 and then 2? That means that 3, 1 is the vertex. So I'm going to write that down in the center here. So I'm going to put the vertex right here. I'm going to put 3, 1 as the vertex. Then I'm going to put the numbers above it and below it. So below that I have 4, 2. I'm going to have to arrow down. I have 5, 5. And then I want the numbers above. 2, 2. 1, 5. So today what's going to quantify or how we know what's going to go in the table is based on where do we find the repeating values. I have 3, 1, which is the vertex, goes in the center. And then I have 2, 2, 5, and 5. They've got to repeat, okay? All right, so let's graph. 1, 5, 2, 2, 3, 1, 4, 2, 5, 5. I do have a U shape, which was what I was looking for. And then we're going to talk about each of the pieces. Okay. The A value is still in front of x squared. There's not a number there, so that means it's a 1. So there's a 1 right there. The vertex we found is 3, 1. The axis of symmetry we talked about yesterday. The axis of symmetry is the line, not yesterday, last week, whenever, that cuts the vertex, the parabola, in half. That is always x equals whatever the x value of the vertex is. So that's 3. The x-intercept is where it crosses the x-axis. It does not cross the x-axis, so we write none. The y-intercept is where it crosses the y-axis. It doesn't look like it does, but it does. So let's look at our calculator and see if we can find where it crosses the y-axis. When it crosses the y-axis, x will be 0. X is 0, y is 10. There's the y-intercept. So 0, 10. Okay. In behavior, when x approaches negative infinity, what does y do? And when x approaches positive infinity, what does y do? When x approaches negative infinity, which is the left, y is going up, so it's positive infinity. When x approaches infinity, the right, y approaches positive infinity as well. Since it is pointing both left and right, eventually we'll see one that's not pointing left and right. Not today, but in another type of function. The domain is all real numbers, so you can remember either write it or put the symbol or write ARN. I will be putting this symbol for the rest of the video. That it's 2 lines and an R. The range is y. This is pointing up, so it's greater than or equal to whatever the y value of the vertex is, and that is 1. Y is greater than or equal to 1. Okay? Once you have that, we're going to open up. We're just going to keep on doing them. Not changing anything. We're doing the same thing. Okay? Number 2. Before we can have the table, we have to put the vertex in the center. We'll have to find the vertex. So press y equals on your calculator. Clear this out. Negative x squared plus 8x minus 14. Second graph. Looking for repeats. And I already have repeats in my table. Sometimes I don't. Sometimes I have to go up and down to finally find them. But here, 1 and 1. So the vertex is 4, 2. Let me turn off that for just a minute so we can see. 4, 2. Okay, and I need the numbers below. 5 and 1. 3 and 1. 2 and negative 2. Now I'm going to have to go down and get 6, negative 2. If these do not repeat, I don't have the right thing. You need to pay attention to that. All right, 2, negative 2, 3, 1, 4, 2, 5, 1, 6, negative 2. This one's going to have an x-intercept. It's going to have more than 1. Okay. A is the number in front, negative 1. The vertex, 4, 2. Axis of symmetry, x equals 4. X-intercept, there are 2 of them. Now, we don't know how to solve them and find them yet, so we are going to be guessing. But after Christmas, we will learn how to solve for them. Okay, we'll find the actual ones. So we're going to guess between 2 and 3. So I'm going to say 2.5, 0. This one's between 5 and 6. So I'm going to say 5.5, 0. The y-intercept I cannot see, but remember, the y-intercept always exists in a quadratic graph. Can't have none, so we're going to have to look. It's when x is 0. X is 0 at negative 14 on the y, so it is 0, negative 14. In behavior, when x approaches negative infinity, y approaches what? And when x approaches positive infinity, y approaches what? When x is going towards negative, y is also going down, so it's negative infinity. And when x goes towards positive infinity, y is going down, so it's negative infinity as well. The domain is all real numbers. The range is y is, it's pointing down, less than or equal to 2. Okay. Pause the video and do 3 and then try 4 and 5. We're going to finish them all together in a second, but go ahead and try as many of them as you can real quick. Okay. Number 3. I'm going to have to turn the light on so we can see the calculator. It's crazy, isn't it? Okay. Y equals, clear it out, 2x squared minus 8x plus 5. Second graph. Looking for repeats. There it is. Negative 1, negative 1, 5, and 5. So the vertex is 2, negative 3. We put that in the center. 2, negative 3. We're going to cross out this bottom one. I should get rid of those. I just forget to every year. And the one above that is 1, negative 1, 0, 5. There's our y-intercept that time. 3, negative 1, 4, 5. Remember, if they don't repeat, we've done something wrong. 0, 5, 1, negative 1, 2, negative 3, 3, negative 1, 4, 5. This does not cross the axis, so I don't want you to think it does, or on the actual point. There we go. Okay, A is 2. The vertex is 2, negative 3. The axis of symmetry is x equals 2. The x-intercept we're going to have to guess. Crosses here and here. We don't know how to solve for it yet. So let's say between 0 and 1 is 0.5. If you put like 0.75 or something like that, that's fine. As long as between 0 and 1, you're correct, because we don't know how to find it yet. And let's say 3.5. Again, any number between 3 and 4, you're going to be fine. You don't have to erase it. The y-intercept is finally on the graph. We don't have to look at the calculator. It's 0, 5. The end behavior, as x approaches negative infinity, y approaches what? Well, y is going up, so it's positive infinity. And when x approaches positive infinity, y is going up, so it is positive infinity. The domain is all reals. The range is y is greater than or equal to, because it is going up, and the vertex value is negative 3 for the y. Okay, not part of this. It's not asking you this, but something I want you to do on 2 and 3, and then on 4 and 5. We talked about this in the last video, is what is this point? This is the highest point, this vertex is. So the vertex for this can also be called a maximum. So write that down up there on number 2. Number 3, this vertex is the lowest point, so it's a minimum. If you ever see the word maximum or minimum, it's talking about the vertex. Just like if you ever see the words roots, solutions, or zeros, it's talking about the x-intercept. I want you to know that all those different words exist, okay? Alright, if you haven't paused the video and done 4 and 5, do that. And also name if it's a maximum or minimum for me. You're pausing the video and trying that real quick. Alright, 4 and 5. Clear this out. Negative x squared plus 2x plus 1. Second graph. Repeat right there. 1, 2 is my vertex. 1, 2. 0, 1, which is my y-intercept. 2, 1, 3, negative 2. And I have to go up to see the next one. Negative 1, negative 2. Negative 1, negative 2. 0, 1, 1, 2, 2, 1, 3, negative 2. The A value is negative 1. The vertex is 1, 2. The axis of symmetry is x equals 1. The x-intercept is something we're going to have to guess. Between negative 1 and 0, negative 0.5. Again, any number you put in between there is going to be fine. Between 2 and 3, the y-intercept is on the graph on this one too. The y-intercept is 0, 1 in behavior. This one is pointing down in both directions, so it's negative infinity for both. Domain is all real, and y for the range. Pointing down, so less than or equal to the vertex value of 2. Remember, I asked you to please tell me if this is a maximum or a minimum. It is the highest point. It is a maximum. The vertex is a maximum. These are root solution zeros. If you haven't paused it for number 5, pause it for number 5. Remember, the nice thing about the video is if I go too fast, and I'm not going slow on purpose, so the video is shorter, but you can pause any time through the video to make it the speed you need it to be. That's the point. I'm not making it fast on purpose. Okay. Number 5. Clear this out. 2x squared minus 8x plus 11. Second graph. Ooh, this one's nice. It's right in between here. There's the vertex, 2, 3. Because it's 5 and 5 and 11 and 11 and 21 and 21. So 2, 3 goes in the center. We're going to cross out the bottom one. 1, 5, 0, 11, which gives me my y-intercept. 3, 5, 4, 11. Again, if it doesn't repeat, I didn't do it right. Mine repeats. I did it right. Remember, sometimes you'll have to move up and down on the calculator's table to find it. That's okay. 0, 11, 1, 5, 2, 3, 3, 5, and 4, 11. A is 2. The vertex is 2, 3. The axis of symmetry is x equals 2. The x-intercept, it does not cross this x-axis this time, so it is none. Remember, don't leave that blank. The y-intercept is 0, 11. It is pointing up in both directions, so the end behavior is positive infinity for both y values, for both ends. The domain is all real. The range is y. It's pointing up, so greater than or equal to the vertex value of 3. Okay, this is the lowest point the vertex is, so it is a minimum. It's important you know the words. Questions use the word vertex, minimum, and maximum all the same. They just change them around. It means the same thing every time. Just like the word x-intercept root solution zeros means the exact same thing every single time that it's said, okay? All right, this is going in your notebook on page 55, I believe. I'm going to check before I just do that. Yes, 55. You're going to label page 55, 19.1, which is what we labeled 54, graphing quadratic functions. Okay, that's all the graphing of quadratic functions we're going to do. We're still going to do some quadratic functions this week, but we're going to do a little different thing with them. I'm not going to graph them anymore. All right, once you got that glued in, you are good to go. Go start working on whatever it is I told you the homework was. I'll see you later.